Here we are with modeling with geometry 5.6. So the first part is finding areas of triangles. Okay. Now, the formula for an area of a triangle, pretty simple, 1/2 times base times height, where this is our height, this is our base. Now, basically what it's wanting us to do is to use trig to find one of those pieces so that we can find the area. So, if I look at number 1, I should notice first off that we've got a 45-degree angle here. This is also a 90-degree, which means this has to be a 45-degree angle. So we have that 45, 45, 90, a special right triangle, which we should remember there's a pattern. Whatever the legs are, they're the same, and then they're that leg length times the square root of 2 for the hypotenuse. So if I look at this, okay, I want to find this h. So I've got a leg here, and that h is a leg. So 5 square roots of 2, well, thinking back to this, thinking back to this pattern, if I get rid of the square root of 2, that's going to leave me the leg. So I get rid of that 2, my legs have to both be 5. So we've got a length of 5 here, a length of 5 here. So my height is 5, my base is 14, so I go 1/2 times 14 times 5, 1/2 times 14 is 7, times 5 is an area of 35 centimeters squared. Make sure you include that length squared. So that one was pretty simple, but we were, given one of those special right triangles, so let's keep moving. Alright, now if we look at number 2, okay, we've got another special right triangle. So that's a right angle right there. That's a 30, which means this has to be 60. So we've got a 30, 60, 90 triangle. And what we found out with those is that the shorter side, the hypotenuse is double the shorter side, and the longer side is that side times the square root of 3. So we've got the hypotenuse here. This is the longer side, this is the shorter side. We've already got our base, so we just need the shorter side. So we take 18, cut it in half, and it's 9, because it would be, twice as big, so it's 9, so the height is 9, base is 38, so 1/2 times 38 times 9. 1/2 times 38 is, 19? 19 times 9 is 171. So 171 centimeters squared for that. Okay, so they're giving us these special right triangles, which is making it a lot easier to have to deal with. Alright, let's look at number 3. Okay, so 60, so this is 30. Okay, so the hypotenuse, because that would be the right angle, is 14, which means the shorter side is 7. Okay, which means that this longer side is 7 times the square root of 3. So, that's our height, that's our base. So the area is 1/2 times 11 times 7 square roots of 3. So we're going to use the calculator on this one. So 1/2 times 11 times 7 times the square root of 3. And that gives us 66.68. I'm rounding. Centimeters squared. Okay. Alright, now we look at number 4. So we need the height here. Okay, so we've got a isosceles triangle, right? Because those are congruent, which means this is 70 degrees as well. Okay. Now, what that's going to do for us is tell us that to find this height, we've got that these two pieces are going to be congruent too. So, because we're bisecting that angle, coming down and hitting it. So that'll be 8 on this side, 8 on that side. So now we can use some trig to help set this up. So we've got our angle right here, which would make this the opposite side, and this is the adjacent. While thinking of SOHCAHTOA, what connects opposite and adjacent? It's the tangent. So I'm going to go with the tangent of 70 degrees is equal to the opposite, h, over the adjacent, 8. So we times both sides by 8. So I'll get 8 times the tangent of 70 degrees equals h. So that's what I type into my calculator, just like that. So 8 times the tangent of 70 degrees, and that gives me h is 21.9798. So we'll go 21.98. So that's our height, right? So for the area, we go 1/2 times the base times the height, 21.98. That's really 1/2 times 16 is 8, so 8 times 21.98. And we get an area of 175.84 centimeters squared. Okay, so that one took a little bit more work because we didn't have that special right triangle, so we had to do a little extra stuff. Okay, now number 5. So we've got a 30, 60, 90. We also have a, since those are congruent, and that's a 90-degree angle, I know that that would be a 45, 45. Okay, so we're going to have to do a few things here because they gave us the hypotenuse, but we need the base here, and we need the height here. But we've got a few things, to help us out. So, if we look at this, okay, erase some of this information. We know it's 45, 45, 90 triangle. So, the shorter side is half the hypotenuse, so that should be 12, which means that piece is 12, which means that would be 12 square roots of 2. Then this longer side would be 12 square roots of 3. Okay, so we're going to add those two together as our base. 12 square roots of 3 plus 12. Okay, which would give us some sort of decimal. But I'm going to let the calculator do most of the work. So the height is 12, so 12 times the base, so that's the height, that's the base, times 1/2. Those two we can simplify, so it's 6 times 12 squared, it's 3 plus 12. Now I'm just going to type this into the calculator just like this. Let it do all the hard crunching, and we get an area of 196.71 feet squared. There we are. Okay, now we've got some story problems dealing with triangles, but we're going to keep going on. So, while traveling across a flat stretch of desert, Joey and Holly make note of a mountain peak in the distance that seems to be directly in front of them. They estimate the angle of elevation to the peak at 5 degrees. So they're talking about this guy, so they're over here. I'm looking, that's what they estimate. There's the top of the peak. After traveling 6 miles, so then they travel 6 further miles, towards the mountain, the angle of elevation is 25 degrees. So that's this guy, this angle. Approximate the height of the mountain in miles and in feet. Okay, knowing that 5,280 feet is 1 mile. While figuring, use at least 4 decimal places. Okay. So, we've got a few things going on here. When we look at this problem, there's some issues going on here. Okay, first of all, we don't know this whole side, and we don't know this side. We don't know the distance. We don't have a hypotenuse. Okay, so we don't know 2 pieces of information for the right triangle, which is either this one or the big one. We know 2 pieces of information for that obtuse triangle, but that's not really, we can't use the trig we know to deal with that. Okay, so stick with me, this one's going to take a little bit to deal with. So the way we need to think about it is like this. Okay, we're going to try to set up two problems. So if I want to figure out what D is, I got this angle 25. This X is the adjacent side. This would be opposite. Thinking of SOHCAHTOA. Okay. What deals with opposite over adjacent? That's the tangent. So tangent of 25 degrees is equal to D over X. Okay, now we can solve for D by multiplying by X. So I get X times the tangent of 25 degrees equals D. So if we know what X is, we can figure out what that length is. Okay. Now let's think about the bigger triangle, the bigger right triangle. So this length down here is 6 plus X. It's also the adjacent side, and D would be the opposite again of 5 degrees. So I know that the tangent of 5 degrees is equal to the opposite D over the adjacent 6 plus X. Now to get D by itself, I can times by 6 plus X, even though I don't know what X is. So I get 6 plus X times the tangent of 5 degrees equals D. Now notice here, this and this are both equal to the same thing. So I can set them equal. So I know that the 6 plus X tangent of 5 degrees is equal to X times tangent of 25 degrees. Okay, now why would I want to do that? Because we're trying to figure out what X is. If we know what X is, we can then figure out what our answer is. Okay, so let's distribute. Tangent of 5 is like a number. And you could put it in a number with 4 decimals, but I'm going to leave it as tangent 5. So I have 6 times the tangent of 5 degrees. So that's a number. Plus X times the tangent of 5 degrees. Not sure what that is. Equals X times the tangent of 25 degrees. Now I want to subtract and get the X's on the same side. Like that. So that leaves us with 6 times the tangent of 5 degrees on the left side equals X times the tangent of 25 minus X times the tangent of 5. Now, we share an X here, so I can take it out, distribute it out, and I'm left with the tangent of 25 minus the tangent of 5, which once again, that's a number, right? Whenever we're dealing with the tangents, sines, cosines, and we have the angle, it's a number. So I'm going to divide by that tangent of 25 minus the tangent of 5. Now, at the very beginning, we could have taken this tangent of 5, typed it in a calculator, see what decimal it is. Same with tangent of 25. But I like to wait till the very last possible second to do that and let the calculator. So that cancels, and we're left with X equals whatever 6 times the tangent of 5 divided by tangent of 25 minus tangent of 5. So that's what I'm going to type into my calculator. Just the way we see it. So tangent of 25 minus tangent of 5. Making sure it's all written in correctly. And I end up with 1.3857, which they said round to the fourth. That's what X is, so 1.3857. A lot of work to get there, right? Clear some space for us. Okay, so I now know that this X is 1.3857 miles, right? So this whole thing would be 7.3857, right? When we add them together. But I only need to find a distance, I only need this one. So I know we knew that the tangent, well, this X times the tangent, so 1.3857 times the tangent of 25 degrees is going to be equal to D. So now I can take that and multiply it together and get 0.6462 when we round equals the distance. Now that's in miles, so it's not quite, it's a little over half a mile, right? So So that's miles, so it's over, half a mile. So if I take this decimal and multiply it by feet, 5,280, it'll get us 3,411.75 feet. That's how tall the mountain is. So quite a bit of work just for that one problem, right? But there we go. That's how we do it. Okay, number 7. Hopefully this one's a bit easier. The Star Point Ranger Station and the Twin Pines Ranger Station are 30 miles apart along a straight scenic road. Each station gets word of a cabin fire in a remote area known as Ben's Hideout. A straight path from Star Point to the fire makes an angle of 34 degrees with the road, while a straight path from Twin Pines makes an angle of 14 degrees with the road. Find the distance d of the fire from the road. So this one shouldn't be so bad, right? So we're looking for this distance right here. So we've got the two right triangles. Okay, we've got this 30 miles. But we don't know what the distance are of these pieces, right? So maybe this one won't be quite so easy. So let's see. We might have to do a similar thing, huh? Let's call this shorter one x. So this one would actually be 30 minus x, right? Then for this, that would be adjacent, that would be opposite. For 34 degrees, that would be adjacent, that would be opposite. So once again, we could go the tangent of 34 degrees is equal to the adjacent over the opposite. No, the opposite over adjacent. Why am I mixing it up? The opposite over adjacent. So we times by x. So we end up again with x tangent of 34 degrees equals d. On the right side, we know that the tangent of 14 is equal to the d over 30 minus x. Yeah, we're basically doing the same thing. Times it by 30 minus x. And that would be equal to d as well. So we get 30 minus x tangent of 14 equals d. The nice thing is it's basically the same process. So we set them equal to each other. I'm going to distribute that. So 30 times tangent of 14 minus x times tangent of 14. Then we add x times tangent of 14 to both sides. Okay, and that would, so we'd get 30 times tangent of 14 equals. Now we add those together. We can distribute out the x. So I'm going to kind of jump ahead a step. So we'd have x times tangent of 34 plus tangent of 14. I can pull out an x because they both have it in their factors. So then we divide by that whole thing. And that's what we're going to put into our calculator to figure out what x is. And once we've got x, we can plug it back in here to figure out that distance. So, second time around, not so bad, right? Maybe. So I type that in just like I have it. We end up with 8.0965 when we round. Okay, which I'm going to actually use the number in my calculator, which is a longer decimal, so my answers might be slightly off. So I'm going to put that right in there, so we get 8.0965 times the tangent of 34. So then we just take that and we multiply by the tangent of 34 degrees. That gives us 5.46 miles, that distance. Alright, so now let's take a look at some more of these special right triangles, okay? So it says fill in the missing sides and angles in the right triangles. Write answers in simplified radical form. Do not use a calculator. So, this one, 45, 45, 90. So, the hypotenuse 16 is equal to the side length times the square root of 2. So if we were to solve this, we'd have to divide by the square root of 2. So the side length would be 16 over the square root of 2. The problem is they don't like to leave it like that, so we'd have to multiply by the square root of 2 over the square root of 2. So you'd end up with 16 square roots of 2 over 2, which 16 over 2 would simplify to 8. So it would be 8 square roots of 2. Where if that's what you had as your side lengths, when you squared and put them together, you'd end up with 16. So you kind of have to work backwards. Okay, same with number 9. Okay, because these are equal, these legs, I know that these are equal, so they're both 45 degrees. So same idea. So 34 is equal to x square roots of 2. So we divide by the square root of 2, which we end up having to times by the square root of 2 over the square root of 2. Those become 2. 34 divided by 2 is 17, so we get 17 square roots of 2. Okay? So, write a rule for finding the sides of an isosceles right triangle when you know basically it's that hypotenuse times the square root of 2 over 2, right, is going to get us that information. That's kind of what we did. Okay, now looking at 11 and 12. Now let's look at the 30, 60, 90. So that's 30 degrees, 30 degrees. Okay, so this long side, remember it's the setup is the short side, the hypotenuse is twice as much, the long side is that square root of 3. Now thinking back to when we had to deal with these square roots, going to be the same idea, right? So we'd go 15 equals, that would be x times the square root of 3. So just the same way, we're going to have to divide by the square root of 3. But when we do that, and we get x by itself, we can't leave that on the bottom. So we have to times by 1, which that times that would give us 3. And then we'd have 15 square roots of 3. But that would simplify to 5 square roots of 3, right? So that would be 5 square roots of 3, and this would be 10 square roots of 3, because 5 times 2 is 10. Okay, and the square root of 3 would just stay there. So same with this one. We go 24 equals x times the square root of 3 divided by the square root of 3. So you can hopefully see that pattern too, kind of similar to what we just did. So we'd end up with 24 square roots of 3 over 3, which that would become 8 square roots of, oh, wrong side, 8 square roots of 3. So the hypotenuse would be 16 square roots of 3. So if we look at 13, write a rule for finding the missing sides when you know the side opposite the 60-degree angle, but it doesn't show that. So it would be the square root of 3 over 3. Whatever that side length is, x, times the square root of 3 over 3. Okay. Now, 14 and 15 wants us to find the missing measurements. So this would be 45 degrees again. That's a side length, so it would be the side length times the square root of 2, and that would be the side length. For the 30, 60, 90, we know the hypotenuse, so that would be the hypotenuse over 2, and that would be the hypotenuse over 2 times the square root of 3. And that would be 60 degrees. So then, it says fill in the ratios for the given functions. Do not use a calculator. So if we think about this, think about the sine of 45 degrees. Well, regardless of which one we choose, that's the adjacent, that's the opposite, that's the hypotenuse. So for the sine is opposite over hypotenuse, so it's going to be s over s square roots of 2. Okay, which that's going to cancel, and we'd end up with 1 over the square root of 2, but we can't have that. So have to times that by the square root of 2 over the square root of 2. So it'd end up being the square root of 2 over 2 when you simplified it. Okay, the cosine would be the adjacent over the hypotenuse, Same thing. So you're going to end up with square root of 2 over 2. The tangent would be s over s, or just 1. Okay, now if we look at number 17, the sine of 30 degrees. So here's our reference angle. So that would be opposite, that would be adjacent, that would be hypotenuse. So the sine is opposite, the opposite being h over 2, over the hypotenuse, which is h. Well, h over 2 divided by h, get the reciprocal and multiply, h over 2 times 1 over h. H's would cancel, leaving us with 1 over 2. So it's 1/2. Now, here's something cool. The cosine of 60, if we went from right here, this would be opposite, this would be adjacent, hypotenuse is still hypotenuse. Well, isn't the cosine of 60 h over 2 over the hypotenuse, h? Isn't that the same thing we just did? So that should be 1/2 as well. Okay. Now the cosine of 30 would be that adjacent h square root of 3 over 2 over, once again, that hypotenuse. So it'd be h square root of 3 over 2 divided by h over 1. So we times it by 1 over h. The h's would cancel, and we'd have the square root of 3 over 2 as we multiplied across. Now thinking back to the 60 degree, that opposite side is the same as the 30 degrees adjacent, so you'd end up with the same thing, so that's square root of 3 over 2. Now the tangent. The tangent of 30 would be opposite over adjacent, so let's clear some space. So the opposite is at h over 2, the adjacent is h square root of 3 over 2. So basically we're dividing, right, by this fraction, but we can't divide by a fraction, so we multiply by the opposite, the reciprocal. H's cancel, 2's cancel, so we're left with 1 over the square root of 3, which we can't have, so we times by the square root of 3, so we get the square root of 3 over 3. Right, because that would become 3, that would become square root of 3 over 3. Now you may want to say the tangent of 60 would be just the opposite of that, so it would just be like flipping those. So it would be h square roots of 3 over 2 divided by h over 2, but then we'd multiply by the reciprocal 2 over h. Those would cancel, we'd be left with the square root of 3. And I should probably put that in blue to match. And there we go, guys. So some crazy stuff there, but that's interesting, and those ratios are very important when we're dealing with trig.